Alright, so Mastering Physics, Physics 184, Chapter 27. This is question number 5. So we're given a 9.3 times 10 to the negative 4 volt per meter electric field creates a 5.2 times 10 to 17 electrons per second current. And so remember, volts per second, or coulombs per second, not volts per second, coulomb per second, which is basically amps. So 5.2 times 10 to the 17 amps. And 1.8 millimeter diameter aluminum wire. So we're asked, what is the drift speed? So as you guys can see the answer here, can't really see the question here, so let me move this down a little bit. Okay, so the drift speed, okay, we need to use the equation, any equation that gives us the drift speed. So a couple things to note here, it gives us aluminum, so from the table 27.1 in the book, you can find the electron density of aluminum to be 6 times 10 to the 28th inverse cubic meters, right? And then the electron, or the mass of electron, is 9.11 times 10 to negative 31 kilograms. So we'll be using this later. Just some things to note here. You might want to put this in your cheat sheet for the quiz on Monday. So let's go ahead and begin. So we know I is equal to NE VDA. So we're trying to find the drift speed, which is this, and we're given everything. We can find this right now. So the drift velocity, right? That's just going to be the current divided by NEA. This looks all too familiar. So ND is equal to I, which is going to be 5.2 times 10 to the 17th electrons per second. So we can't quite use that just yet because we need to convert the electrons to coulombs. When I was reading that, I was a little bit confused myself. So we have 5.2 times 10 to the 17th electrons. We need to convert this to a charge in coulombs. So we know one electron creates a charge of negative 1.6 times 10 to the negative 19 coulombs. So the electrons will cancel. Let me just do this math on the calculator real quick. That'll be 5.2 e to the 17th times negative 1.6 e to the negative 19. So we'll get negative 0.0832 coulombs, and that's per 1 second. So if we divide it by 1 second, that'll give us coulombs per second, and 1 amp is 1 coulomb per second. So if we just divide it by 1, that'll just be itself. So it is equal to negative 0. I forgot decimal. Yeah, negative 0.0. I guess the decimal place was supposed to go right here, 0.0832 amps. Okay, but I guess you don't have negative current, so it just means that our current is going the other direction of which we assumed, so we can just forget about that negative sign, right? Yep. So because you're not going to have negative current. Okay, that doesn't make any sense. So now we can use the equation as 0.0832 amps. But in this case, let's go ahead and leave amps in coulombs per second, so our units can cancel. So the denominator we have n, again, using the table 27.1, we have n as 6e to the 28 1 over meters cubed. And then we have E, which is the charge of an electron. That's just going to be 1.6 times 10 to the negative 19 coulombs. And then even if we did keep the negative sign, I guess it'll cancel out with this one, so you guys can see. But just forget about it. Okay, that's not a 4. I don't want to confuse anyone here. So in the area, well, let's go ahead and find the area because it gives us the diameter to be 1.8 millimeters. So again, the area is just going to be pi 1.8 e to the negative 3 divided by 2 squared, because pi are squared, right? So let's go ahead and type this in our calculator. That is 2.254 e to -6 meters squared. Meters squared cancel with this cube right here. Coulombs cancel with coulombs. This flips, so we get meters per second, which is velocity. If we were to type this on the calculator, if you give it a second here. So 0.0, I'm trying to find this number. We are going to get 3.41 times 10 to the -6 meters per second. And as you can see, it matches up with our answer up there. And so that's how you do this one. So now the other part is, what is the time between collisions? And they all already gave us the symbol for it, tau. So looking at our equation sheet, the equation for tau is m times, well, mass. That's the mass of an electron. V is the drift velocity, which is what we just found. So keep that answer handy. And then E is just a charge of an electron. And then E is the electric field, which they gave us right here. So we just have to plug and chug. So I'm just gonna go ahead and erase this stuff so we have more room to work with here. So yeah, let's go ahead, scroll back up a little bit. So we have tau is equal to mass of an electron, which is right there, 9.11, e to the -31 kg. I'm actually not too sure if it's gonna cancel if anything, but we should see. The velocity was 3.41 times 10 to the -6 meters per second. Charge of an electron, that is just 1.6 times 10 to the -19 coulombs. An electric field, well, the electric field, that is just 9.3 times 10 to the -4 volt per meter. So now if we type this on the calculator, we will get let's go ahead and check my math here. 3.4. Okay, so if we multiply that by the mass of the electrons, that's 9.11 e to the -31. And we have 1.6 e to the -19 times by the electric field, 9.3 e to -4. We get -2, -2.08 or -2.1 times 10 to the -14th seconds. And that is it, guys.